So today I'll be talking about information system design, and I'm going to delve into um, discussing questions and answers directly. Here I have sieved the questions from information system design, from easy questions to difficult questions. So we're going to be starting with 10 easy questions before we delve to the difficult questions, 10 difficult questions. So that you might expect in any sort of exams for information system design and analysis. First, let's move to what is system design analysis. Here, you'll find out that the definition of system design analysis is pretty straightforward. System analysis is a process of examining and understanding a system to identify its components, relationship, and functioning. So you should understand here that system analysis is the process of examining and understanding a system to identify its components and the relationship between the components and how they function. Now, um, the keywords here, it's the process of examining and understanding a system to identify components and relationship and functioning. So the keywords here should be system analysis is the process of examining and understanding a system in order to identify its components. So let's take this as the definition. Please let this stick because this is what the whole course is all about. Understanding the process of examining and understanding a system to identify its component relationship and how they function. It involves studying the system in detail to gather information and understand the requirements and purposes, purpose, improvement, and solution. So this involves studying the system in detail, gather the information, understand the requirements, and propose improvement or solution for the system. System analysis is often the first step in the development, in system development. It aims to ensure that new system meets new user and works efficiently. So an example here is a retail company analyzing its current inventory system to determine inefficiencies such as delays in restocking and to improve its overall functionality. So this is an example of system analysis. So we'll move on to the next one. Explain any five elicitation technique of system analysis. Elicitation techniques are methods used to gather requirements and information from stakeholders about system. Remember, the stakeholders might be internal or external. So elicitation techniques are methods used to gather requirements from stakeholders about the system. The first elicitation technique is the interview, one-on-one or group session where analysts ask stakeholders questions to gather information. So the first here is description. So a typical example here is in interviewing store managers to understand their inventory challenge. Two is observation. These are elicitation techniques. You can watch how users interact with the current system to identify process and issues. Like we have said earlier on, that system analysis is understanding and identifying how system components is examining and understanding a system to identify its components and relationship and functioning. So, so here we talk about observation, watching users how they interact with this current system to identify process issues. Observation, that's the description. Example, observing a cashier using POS system to identify time consuming taxes, to identify those taxes that are difficult and time consuming. Three, we have survey and questionnaires. Please understand that interviews are one-on-one discussion or group discussion to elicit uh, answers and opinions from the group, especially stakeholders, to gather information. Survey and questionnaires. Survey structured forms. Survey structured forms distributed to stakeholders to collect information about their requirements and opinion. One good thing and the differentiation between survey and interview technique is the interview can really be used for folks that are not really educated. And the survey, you have to be literate, able to read and write to use it. So structured, that's why structured is distributed. So that's the difference between the survey and the questionnaire method. Sending a survey to customers to gather feedback, for example, on a website use, ease of use. Like the DSTV app, when you finish, there used to be a short questionnaire. Did you enjoy it? How easy it is to use? That's just a very short questionnaire, short survey. And four, document analysis. Document analysis is reviewing existing documents, such as usual manual reports, flowcharts, and to understand the system. A typical example is analyzing financial reports to identify uh, trends and system needs. Five, prototyping. Prototyping is creating preliminary version of a system to gather feedback and refine the requirement. It's developing, example, developing a basic model of a new mobile app interface, showing it to users for feedback. So that is prototyping. Create a prototype of the original, just use it as primary version to gather information. Um, But moving to the next question now, it says list and explain five components of information system. We talk about five components of information system: the hardware, the software, the data, the people, and the process. First, let's start with the hardware. Physical devices used to operate and interact with the system. Those are all the physical components. And this should take in form of uh, we should talk about servers. We should talk about the servers. We should talk about um, um, printers, network devices, and computers. Those are physical. Those are the hardwares. Talking about the software, programs and applications that run in the hardware to perform tasks. Remember, the hardware is the physical, like computer, server, printers, and network devices. The software are the programs and applications that run on the hardware to perform tasks, such as Microsoft Excel for data analysis. We have SPSS for data analysis. We have ERP, which is a software for managing business process, and several others. We have data. Data is raw facts that and figures processed into meaningful information. So raw data, facts, and figures processed into meaningful information. So we talked about sales records. When you process it, it becomes very meaningful information about the volume of sales, uh, level of sales, customer information, inventory, and most sold products was from the sales record when the data has been given meaningful information, when it has been processed into meaningful information. We have the people. The people, for example, here. are the users of IT or the IT staff, the users and IT staff who interact with the main system, with who interact with and maintain the system. So system administrators, end users, data analysts, program managers, we have product managers. These are people who use the system, IT specialists, and all the others. So we have processes. Here, processes basically is going to be the description of processes, rules and procedures, and flow works that govern the system operation. So a flow work for order processing in e-commerce is a sample of a process. Let's go to define the term system design. System design here can be defined as system design is the process of defining the architecture and the component and interfaces and that and data of a system to make specific requirements. Please don't forget this definition. System design is the process of defining architecture, components, interfaces, and data of a system to meet specific requirements. It acts as the blueprint for system construction, ensuring that system fulfills user need efficiently and effectively. So we can say it's the blueprint, it's the architecture, it's the components, the interfaces, and data of a system to meet specific requirements. It acts as a blueprint for system construction, ensuring that system fulfills the needs of users efficiently and effectively. Example, in designing an e-commerce platform, the system design would include a user interface layout, a data schema of storing products, and you have customer data and integration with payment gateways. So that would be like the system design to develop an e-commerce platform. The interface layout, user interface layout, the data schema of for storing the product, storing product, and the consumer's data, and we have customers data rather, yeah, and the integration of payment gateways. Let's move on. We have here the fifth question. This fall under easy category. List any 5 examples of hardware and any 4 softwares of software. The hardware is the monitor, which displays the outputs for users under the hardware examples. We have like the LCD and LED screen. The keyboard is a hardware. It inputs commands for typing, like typing commands. It's an input device for typing commands. Example, mechanical keyboard for programming. The mouse, it interacts with graphical interface. That is a hardware. The printer outputs uh, uh, the printer outputs documents in physical form. Yeah, example, laser printer with high quality prints. Then we have the hard drive. The hard drive stores data permanently. It can be found in solid state drive for faster performance and also HDD, which is a little bit slower than solid state drive. HHD or HDD. Uh, we have our software examples. Operating system manages hardware, software resources. One, we have Office, we have Microsoft, Windows, we have Mac OS, and we have all Linux. So those are operating systems, those are softwares. We have web browser, accessing and interacts with internet. We have like Mozilla Firefox, and we have Chrome. When you move further, you see word processor creates and edits documents. We have examples of it is uh, um, Microsoft Word and Google Docs. We have database management system, DBMS, manages data like MySQL and Oracle database. Another one, we have photo managers, or photo editors like Adobe and the other ones. Here, so we list 5 examples of physical system. List 5 examples of physical system. A physical system is a tangible system made up of components that interact to achieve a specific function. We have a car engine system combines mechanical and electrical components for power to power the vehicle. Air conditioning system which regulates the temperature and humidity in a room. We have the traffic light system. It controls the flow of vehicles and pedestrians at intersection. We have the irrigation system which supplies water to agricultural fields systematically. We have the elevator system which moves people and goods between floors in a building. Those are 5 examples of physical system. Physical system is tangible system made up of components that interact with one another to achieve a specific function. So we are moving down to question 7 now. Question 7. What do you understand by the term cohesion? Cohesion is a system design. In system design refers to the degree of which elements of a module and component work together to achieve a single and well-defined purpose. So here it said cohesion in system design refers to how elements of a module or a component come together to achieve a single and well-defined purpose. High cohesion indicates that the module has a focused functionality, making the system and maintainable and users reliable and maintainable and easier to understand. So that's high cohesion. So a module in library management system dedicated solely for issuing books should not handle unrelated tasks like tracking employee attendance. Yes, yes, yes. So when you've developed a module which is uh, which has cohesion in library management system, it's very good in what it does. It's focused functionality. You see high cohesion, focused functionality. So when you develop a module in library management system dedicated solely to issuing books out, should not handle unrelated tasks like tracking employee attendance. Employee attendance is a completely unrelated task to issuing books. So a module should be able to uh, handle a well-defined purpose. Yeah, so this is it. So let's see here. We should be able to differentiate between hardware and software of a computer. What aspect of hardware? Let's go to definition, example, function, dependency, and modifiability. First, the hardware is a physical, tangible component of the system. Yeah, software is a set of instructions and programs that run the hardware. The hardware depends on softwares to run. The hardware runs the software. So you see the set of instruction or program that runs on hardware. So the software depends on the hardware to run. So the physical and the tangible components of a computer system. Examples: CPU, monitors, keyboard. That's example. Operating system, application, utilities. Those are examples of software. Functions, they provide a physical framework for and operational capabilities. That's the hardware. The software execute and data, tasks and execute tasks and processes data. So dependency cannot function without software. Yeah, if you have hardware, a computer there with no software on it, it can't run. Requires hardware to operate. So they are symbiotic. As the hardware cannot function without software, so the software cannot function without hardware. That's dependence. So we did that. Modifiability requires filter changes and upgrade. You can upgrade your RAM, you can upgrade your HDD or SDD, and or SSD, and then you have can be updated and modified digitally. Yes, you have upgrade for antivirus softwares, you have upgrade for Microsoft Word, you have upgrade and for other softwares. Example, a printer used to be output document. In software, a printer driver enabling the computer to communicate with the printer. This is how they work. So their dependability. Number nine, list and explain components of computer peripherals. First, let's understand what are computer peripherals before we go ahead to uh, computer peripherals are external devices connected to the computer to enhance its functionality. These inputs and output devices. So when we go to the input devices, devices used to input data into a computer, such as keyboard, mouse, and scanner. You, you see they are giving input data into the computer. Those are input devices. Also functions and allows users to communicate with the system. That's how they function. For the output devices, devices that display or produce output from a computer. The monitor is an output device. If you type something in, it displays for you. Like now, with this mouse, I'm still hovering over inputs and I've been able to put this is input. And then, so me seeing it turn yellow, it's the output. So that's why they say devices that display and produce output from computer. That's monitor, printers, and speakers. So I'm speaking right now. The speakers are taking in inputs. And so some can perform dual function because the speakers now, not the speakers, the earphones now are taking in what I'm saying and then the speakers will bring it out. So this is for output. The function displays visual output, prints documents, and plays sound. So storage devices, we have definition. Storage devices, we have uh, device used to store data externally. Those are storage devices. Device used to store data externally. So these are some of the peripherals, storage devices used to store data externally. So like flash drive, external hard drive. The function provides additional function and portable storage for data outside the computer. Communication devices. Devices that enable computer connect and communicate, such as modem and network interface cards. We have uh, functions facilitate data exchange between device system. Power devices. These supply power to the computer or other peripherals. Example, uninterrupted power supply, the UPS. Then we have uh, functions. It enables consistent power and protects against surges. Now we have the difficult questions here now. We're halfway done. We have a difficult question here. Discuss five methodologies of system analysis. There are five methodologies. Here are five methodologies. System methodologies are structured approaches used to investigate system and its requirement. So the methodologies of system analysis are methodology structured used to investigate the requirements and investigate a system and its requirements. So moving further, we'll talk about waterfall model, a linear and sequential approach where each phase must be completed before the next phase begins. That's waterfall model. Each phase must be completed before the next phase begins. Developing payroll system where requirements are fully documented before moving to design and implementation. That's a waterfall model. Agile model. It's an iterative approach emphasizing collaboration, flexibility, and incremental delivery, meaning that building e-commerce platform in sprints where with new features delivered every 2 weeks. We have prototyping. It's a methodology to creating an early version of a system to gather users' feedback and refine requirements. Design prototype of a banking app to test user interface and navigation. Structured analysis and design model. A formal, a formalized approach using data flow diagrams and entity relationship diagrams for system analysis. Analyzing hospital management system using data flow. This use data flow diagram to model patient data movement. So the last one here is object-oriented analysis, OOA, object-oriented analysis. Description focuses on analysis of system in terms of objects and their attributes and interactions. Analyzing library management system like book, then objects and their attributes, member, loan, interactions, book, member, loan. So we are moving to the second question. We're explain five phases of system design life cycle, system development life cycle, SDLC. The first stage is the planning, defines the scope, objective, and feasibility of the system. It helps to determine feasibility of automotive university, for example, automating university student registration process, determining the feasibility. Yeah, so this is just about feasibility, scope, and objective. That's the planning. Then analysis. When you talk of analysis here, you are going to be talking about uh, gathering and analyze user requirement to understand current system and propose solution. So that's the analysis. Or so gathering user requirements and analyze them to understand to understand the current system and propose solution, or to understand the type of system to develop and solution it's going to solve. So we're going to be having the next one, which is, so for example, intervene students and faculty to identify issues of existing manual registration system, of the existing manual, then you now create the new one. That's the analysis. So after you plan, you analyze, you design, then that's under the system development lifecycle. You design, create a blueprint for the system, including architecture, interface, and database design. That is where the designing database schema to store student information effectively. So implementation, build and develop the system based on design specification. So you implement what the design is saying and what the blueprint is saying. Follow the blueprint, the architecture, the interface, and the database design to develop and build and develop system based on design specification. Developing a web-based registration system, for example, and developing it for student use, which is the maintenance. They need to be the system needs to be monitored. So you monitor the system, fix issue, updates as necessary. Example, updating registration system to include new courses and options. So this is it for SDLC, right? if I'm correct. That is it for SDLC, System Development Lifecycle. You plan 1, 2, you analyze, 3, you design, 4, you implement, and then you maintain. Example, explain rather, is question 3, decomposition in relation to system design. Decomposition is the process of breaking down a complex system into smaller, manageable system components or modules. Remember, we discussed cohesion. Cohesion we defined earlier on as uh, the working together of all components of a module to it refers to the degree which all elements or component of a module work together to achieve a single and well-defined goal. Here, cohesion now is breaking down here the composition now is breaking down a complex module into or a complex system uh, into smaller manageable components or modules. So it simplifies system design. It simplifies system design, simplifies system development. It helps easy maintenance by isolating individual functions. For example, in e-commerce, the composition might separate functionalities into modules, user management, program catalog, product catalog, and we have order processing and program gateways. So after the composition, let's see, explain the term coupling in system design. Coupling refers to the degree of interdependence between modules in the system. Coupling refers to the degree of interdependence between modules of a system. Coupling operates independently, and low coupling is modules operate independently and interact minimally. That's low coupling. So um, the term coupling in system design. Is it similar to what we described earlier? A cohesion, and the other one is this one is coupling. So let's take note. Coupling is coupling. Let me see it again and get a small definition for it. A more operative definition refers to the degree of interdependence between modules in the system. So this is interdependence between the keyword here is degree of interdependence between modules in the system. Low coupling, high coupling. Modules operate independently and interact manually. High coupled modules are highly dependent of each other. Example, a payment module tightly integrated in inventory module, with the inventory module making changes to one affect the other, and low coupling with a reporting module that only pulls data from database without depending on other module logic. So inside here, the low coupling is preferred as it makes the system more flexible, maintainable, and easier to test than high coupling, where they are highly dependent of each other. Please take note. Um, Provide a discourse on 3 basic types of information system. So we have operational support system, we have management support system, we have strategic support system. So the operational support system handles day-to-day businesses and operations and transactions like the point of sales in a retail store for processing sales and generating receipt. Management support system provides summarized and analyzed data to managers for decision making. So that's the management support system. A sales dashboard showing monthly revenue trends to sales managers. That's an example. Strategic support system here basically aids long-term planning and strategic decision. Long-term planning and strategic decision. Enterprise resource planning system used to integrate and manage companies' wide processes. We have here inside each of these type of support system different in organizational levels, ensuring smooth operations informed decision making and long-term growth. As the first one, operation support system is for day-to-day operation of the business and transaction like the POS, uh, point of sale system in a retail store. Management support system provides summarized, analyzed data to managers for decision making. It's used at the managerial level. For example, it says that showing monthly revenue trend to sales manager. Strategic support system is long-term planning and strategic decision making. Enterprise resource planning system used to integrate and manage company-wide process. So let's go now to explain explain three types of information system. Um, three types of information system. Let's see the similarity between this and the last question. Here is the basic type of information system. Basic type, three basic type. And here is explain three types of information system. Transaction supporting system, transaction processing system. Let me see if it's different for the first one. Operational support system, management support system, and strategic support system. Here we have the transaction processing system, handle routine day-to-day. This and ensures data integrity. ATM used in the bank to process withdrawal, deposit, and balance transaction processing system. Decision supporting system DSS help in decision making, analyzing large volumes of data and generating report. A system that analyzes sales to identify the best performing product in trade. Expert system ES mimic human expertise to produce recommendation and solution. A medical diagnosis system that suggests possible condition based on patient system symptom that have been taught by expert support system. List and discuss four system design tools. We have the data flow diagrams. So description, it visualizes the flow of data within the system, showing the process, stores, data stores, and external entities. A DFD, for example, for online shopping system illustration shows customer orders flow through the system. And then we have entity relationship diagram. Entity relationship diagram, what does this do? We have entity relationship diagrams. It does represent data entities and their relationship, useful for database design. So ERD showing entity relationship diagram showing students, courses, enrollments in a university. So on unified, that's a unified unified modeling language, UML, unified modeling language. It's here a standardized set of diagrams to model system architecture, processes, and behavior. UML uses case diagram for airline reservation system, for an airline reservation system. Flowcharts. We have here flowchart is represents sequences of operations and decision of in a process using symbol. Flowchart is an inventory, for example, a flowchart for inventory system illustrating the steps in restocking the product. Go down here, we have discuss five ways information system analysis and design assist an informational professional, assist information professional. So information system analysis design, how it assists an information, improve decision making, detailed analysis, and organized data to support informed decision. Analyzing customers' behavior will improve market strategies. So enhancing information identifies inefficiencies in existing system and suggests improvement. Example, reducing orders, order processing time by automating manual tasks These are efficiency enhancing, so it helps to identify efficiency in the existing system and suggest improvements. Ensuring scalability, it ensures this data system that can grow with organizational need. A system designed to handle growing customer base in an e-commerce platform. Scalability ensures that with growth, as the company grows, it can take care of it. And then we will move to uh, briefly discuss improve users satisfaction. Sorry. Number four, tailored systems to user need, ensure better usability and performance, improve user satisfaction, facilitating integration, ensuring seamless integration with other systems in the company and other processes. New integration, integrating example, integrating an accounting system with existing inventory system. Brief discussion, briefly discuss 5 features of a system. First, interconnectivity. The components, 5 features of the system. Interconnectivity, the components are linked and communicate with each other. Sensors of a smart home system communicating with central hub. Two, purpose. Every system is designed to achieve a specific goal. A library system aims to manage books, loans, and return. Boundaries. Uh, boundaries, we see systems have defined limits separating them from the environment. A bank internal system boundary separates it from external network. Inputs and outputs. System require inputs to produce outputs. So manufacturing system receives raw materials, that's the input, produces finished good, which is the output. Feedback mechanism. System use feedback mechanism to improve, to adjust and improve its operation. Its operation. Its operation. So example, a thermostat adjusting the temperature based on the room condition. So we have here explain the term modularity in system design. Modularity refers to designing a system as a collection of independent, self-contained modules that can function together. So I'll take it again. Modularity refers to designing a system as a collection of independent, self-contained modules that function together. Each module performs a specific task and interacts with the other module through well-defined interface. In a car manufacturing system, the engine module handles engine assembly, the chassis module handles the chassis design, and then both can operate independently but work together to produce a car. So, insights, advantages of modularity: easier to debug and maintain, simplifies systems upgrade and scalability, promotes uh, code usability. So that is it. I'll take modulability again. Modulability refers to designing a system as a collection of independent, self-contained modules that can function together. Each module performs specific tasks, and also interacts with other modules through well-defined interface. So thank you.